What is m? M is the mass of the body. What is v? V is the velocity of the body, whereas r is the radius. If you are driving your car with this optimum speed, the risk will be minimal. If you cross this optimal speed, the risk will get higher. Once a body is moving in a circular path, its acceleration is given by centripetal acceleration, which is A is equal to V squared by R. Hello students, welcome to this third session on chapter 4, Laws of Motion. I am Madhu R from the Department of Physics at Vidhyaashram PU College, Mysuru, your temple of excellence. Let us recall what we did in the previous session. In the previous session, we had an elaborate discussion on conservation of linear momentum, the common forces in mechanics, the contact forces and the non-contact forces, the normal reaction and the friction. Our discussion on friction was quite elaborate, where we discussed about the classification of friction, okay? The types of friction, the laws which govern the friction, the advantages and disadvantages of friction, and the methods employed to reduce and to increase the friction. Okay? Let us move on today and check what is centripetal force and how a vehicle moving on a flat or horizontal surface or on a banked surface, what is the force acting upon it and what is the maximum velocity with which it can take a turn on a circular path. Let us go ahead. What is centripetal force? Okay, it is the radially inward force. Okay, suppose a body is moving along a circular path. Okay, it is the radially inward force. It is acting radially towards the center of that circular path. Radially inward force acting on a body which is executing a uniform circular motion. What is it given by? It is given by Fc is equal to mv squared by r. What is m? M is the mass of the body. What is v? V is the velocity of the body, whereas r is the radius. Okay, so this is centripetal force. There is one more important terminology which we had discussed in the previous unit, which is centripetal acceleration. What is centripetal acceleration? It is that acceleration which is acting on a body which is executing the circular motion. Once again, a body is traveling along a circular path. The acceleration of that body is called as centripetal acceleration. It is given by V squared by R, where V is the velocity and R is the radius. Okay. Now, let us check how the motion of a car on a level road in a circular path behaves. Okay. Please note here, this is a circular path. What is the radius of the circular path? The radius of the circular path is R. Once a body is moving in a circular path, its acceleration is given by centripetal acceleration, which is A is equal to V squared by R. Okay. Now, if you observe, this is a flat surface or a horizontal surface on which a car is moving in a circular path. What are the forces acting on it? The weight of the car is acting, which is W is equal to M into G. A normal reaction to this weight is acting upwards in the opposite direction, which is N. And then there is friction between the tire of the car and the surface of the circular track, which is F. Okay. Consider a car of mass M going around a circular path of radius R with a constant velocity V on a level circular road, which is as shown in the figure. Three forces, as I said, will be acting on the car. The weight of the car, which is mg, the normal reaction N, and the frictional force F. Since there is no acceleration in the vertical direction, okay, the normal reaction balances the weight of the car. For a flat surface, normal reaction is given by M into G. Let this be equation 1. Okay. Then, in order to have circular motion, the centripetal force should be balanced by the static frictional force. Okay. Static friction opposes the tendency of the car to slide away. Suppose this car is moving on this circular track. Once it makes a turn, this car may tend to slide away. This is avoided by the frictional force. The centripetal force, as we already know, is given by F is equal to mv squared by r, where r is the radius of the circular path. We also know that Fs is equal to or less than mu s into n. What does that mean? Okay, if I substitute back, mv squared by r is equal to mu s into m into g. Please remember mg is n. Okay. Now let us equate v square is equal to mu squared r mg by m. M and m gets cancelled. V square is less than or equal to mu s into r into g. Mu s is the coefficient of static friction, r is the radius, g is the gravitational force. Okay. So for a given value of mu s and r, maximum speed of circular motion is given by V max is equal to square root of mu s into g into r. Okay. If the car exceeds this speed, sliding will begin and the car will no longer travel in a circle. Instead of moving in a circle, this car will slide and probably end up somewhere here. Okay. So that is motion of a car on a level road, the maximum speed with which it can take a circular motion. Okay. Let us move on and check what is called as banking. What is this term called as banking? It is the process of raising the outer edge of the curved road above the level of the inner edge. So once again, the car is moving on a circular path. This outer edge is raised by some angle theta when compared to the inner edge. You can also observe this photo where this is the inner edge and this is the outer edge. There is a slight banking or lifting of the outer edge when you compare it with the inner edge. This angle of banking is the angle between the inclined surface of the road and the horizontal. So if this is the horizontal, if this is the inclined road, this becomes angle theta. Angle of banking plays a very important turn in determining what is the maximum speed in which you can take a circular motion. Okay, let us check that. Motion of a car on a banked road. So a car is traveling on a circular path in a banked road with banking angle as theta. As usual, the weight of the car is acting downwards, which is mg. What are the other two forces acting? There is a normal to the path or normal to the surface on which the car is moving. Since it is at an angle theta, okay, the forces can be resolved as n cos theta in the y-axis and it can be resolved as n sin theta in the x-axis. Of course, there is the frictional force between the tire and the surface. Now this F is also at an angle theta with the horizontal. So what do? I resolve it. In the x-axis it becomes F cos theta. In the y-axis towards the center of the earth it becomes F sin theta. Okay, so please remember there are three forces: the weight, the normal reaction and the frictional force. The normal reaction and the frictional force are at an angle, so we have resolved them. Let us have a look. Consider a car of mass m moving with a speed or velocity v on a banked road with radius r. Let theta be the angle of banking with frictional force F acting between the road and the tire of the car. As there is no acceleration in the upward direction or in the vertical direction, the net force along this direction must be 0. So in the vertical direction, because there is no acceleration, the forces can be equated. Please check, there is n cos theta towards the upward side, F sin theta and mg towards the downward side. So n cos theta is equal to mg plus F sin theta. Let that be equation 1. Centripetal force is provided by the horizontal components of n and f. So let me take the horizontal components of n and f, which is f cos theta and n sin theta. What does they give? They give you the centripetal force, which is mv squared by r, which means that n sin theta plus f cos theta equals mv squared by r, where m is the mass, v is the velocity, r is the radius of the path. When the velocity becomes maximum, or if you want to turn the car with maximum velocity, static frictional force max is equal to mu s into n. Okay, so equation 1 and 2 becomes, if I have to substitute mu s n in case of s, n cos theta equals mg plus mu s n sin theta. This is in place of f previously. Similarly, n sin theta equals mu s n cos theta, mv max squared by r. It was mv squared. Because we have taken the maximum velocity, it has become mv max squared by r. This is equation 3 and equation 4. Have a look at equation 3. N cos theta minus mu s n sin theta equals mg. What do I observe? I observe that n is common. Let me take it as common. N into cos theta minus mu sin theta equals mg, or n is equal to mg by cos theta minus mu sin theta. In place of n in equation 4, let me use mg by cos theta minus mu sin theta. Okay, so if I substitute for n in equation 4, I get it as mg into sin theta by cos theta minus mu s sin theta plus mu s mg cos theta by cos theta minus mu s sin theta plus mv squared max by r. Okay, this is rather equals to. Okay, now there is a common term m. So let me cancel this off. So once I cancel this common term m, what do I get? V max squared equals rg into sin theta plus mu s cos theta by cos theta minus mu s sin theta. What do? I have got a lot of sin and cos here. Let me divide both the numerator and the denominator by cos theta. What does happen? V max squared equals rg into sin theta by cos theta plus mu s cos theta by cos theta gets cancelled, divided by cos theta by cos theta minus mu s sin by cos theta. Obviously, this sin by cos and this sin by cos can be written as tan theta. So, V max square becomes Rg tan theta plus mu s by 1 minus mu s tan theta. So, what is the maximum velocity with which the car can take a circular turn? V max is given by square root of Rg into tan theta plus mu s by 1 minus mu s tan theta. That is the equation that is required. This should be the maximum safe speed of the vehicle on the banked road. Higher speed than this can cause an accident. Now let us come to one important last topic regarding optimum speed. What is this optimum speed? Optimum speed is the most favorable speed for efficiently using the car. What do you mean by this efficiency? The fuel efficiency obviously plays a role, and the maintenance of the parts. How do we do that? By balancing the performance with minimal wear and tear and fuel consumption and the risk factor. If you are driving your car with this optimum speed, the risk will be minimal. If you cross this optimal speed, the risk will get higher. Now, how does mathematically do we understand this part? For mu s is equal to 0, static frictional coefficient to be 0 between the road and the tires, the safe maximum speed is given by V max is equal to square root of Rg tan theta. For optimum speed, V max is given by square root of gr tan theta. The banking angle theta is given by tan inverse of V naught squared by gr, where V naught or V max is given by maximum speed of the car. Theta is the banking angle. G is the gravitational force, and r is the radius of the circular path. Have a wonderful learning experience. Thank you.